Okay, so let's continue. Here. So have a look on the parallel capacitance, or they call as a parallel plate capacitor. So in this part, you may have a look. They shows you have a conductivity plates, or we say as a conducting plate. With the first one as a first layer, the second one as a second layer. Okay, or we call as a first plate, or we call as a second plate. Between the plates, we have dielectric. Okay, so this dielectric where we call as a insulating dielectric. Okay, the mediums is where we stand for dielectric. And at the same time, when you see on this figure, just have a look on the figure here. Okay, and where they call where they specific based on the A, and where they also specific based on the D. So when they say A means the one is based on the area. Okay, A means the one they defined here is area. So area of the plate is how much we need to know. Okay, and the same goes to your the word alphabet D. Okay, is where is based on the dielectric, the thickness of the dielectric. Okay, so they have a difference when you have a lesser. Okay, based on the thickness, you have a more deeper, or you have a smaller thickness. Okay, between the layer, there's also affected the moments of the we call the moments of ion, positive ion or the negative ion. Okay, so have a look on the second figure here. In the second figure here, it shows you based on the moments of the electron. How is it works? Okay, usually we say based on the positive is going to the negative. But in terms of the figure, it shows to you is based on the polarity of the positive polarity with the negative polarity. Okay, take note. When they specify for you based on the plate or based on the capacitance, usually the first layer we always say as a positive layer. This one, okay, we always consists of positive ion. Okay, when they say the second layer always which is related to your negative ion. Okay, so that's the one Miss want to point out here. Okay, and also based on the moments of the electron. How is it works based on the moments electron? It's based on the loop. Okay, the direction of the loop area. Okay, is where you can see the ion move from the first plate going to the second plate. Okay, let's see. You can see in the next slide here. Okay, have a look on this slide. Okay, and actually on this slide they give you some how to say, they give you a clue. Okay, based on the how you understand the concept of a capacitance, how you understand the concept of area with the distance here. Okay, so they have a four figure here. Okay, this is a figure number one. Excuse me, figure number two, figure number three, figure number four. Okay, and where figure 1 and figure 2 we counted as a 1, 3 and 4 we counted as a 1. Okay, so from here you may have a look. They have the source. Okay, this is the one we call as a battery source, polarity positive with the negative, and at the same time you can see it's connected. So take note, the line they shows you, the thing they draw here as a line is where stand for the conductivity, or we say it's called for the wire. Okay, and where it's connected to a capacitor. So think about these plates where stand as a capacitor. Okay, and where we have the A as a positive charge, and we have the B as, sorry, we have, this is the first plate, this is the second plate. Okay, so first plate positive charge, the second plate which we consist of the negative ions, and between these two plate we have the D. So D means is the distance between the A with the first plate with the second plate. Okay, and where the one that is specific for you positive Q means is the charge. Okay, related to the positive charge which is related to the negative charge. So now you have a look on the second figure here. In the second figure, actually the first figure with the second figure is the same thing, but the only thing that make you confused here is where based on the size of the plate, or we call as the dimensions of the plate. Okay, example, based on this one they put as A means stand for area, so they just put as A. But when you have a look on the second figure, they wrote for you as a 2A. It means the size or the dimensions of the plate is a double time from the first figure. Okay, so that's why you can see even from the image you can see they draw slightly smaller plate, this one slightly a bigger plate. Okay, and where the distance between it they try to keep the same measurements. Okay, so it also can increase, they also can decrease. The distance, take note, the distance also sometimes is the factor of affecting based on the capacitor. Okay, if the distance between the two plates is too huge, okay, they have some we have some energy gap between the two plates. Okay, the ion is a bit hard to move from one point to the next point. If too small, then we can't see the movements happen between the first plate and the second plate. It also can have a short pattern. So what Miss try to say, okay, example, you just think this is, you have the plate A, this is your plate B. Okay, so it means when we have a current flow, of course we need to pass through based on your plate A with the plate B. So when you have the big gap, okay, so it means the charge going to move from A to B plate will be take long time. Okay, and in case you have the plate A and you have the plate B, it's too near. Okay, when it's too near, or we say as an overlap, it can happen a short pattern. Okay, it means the movements between the ions is not proper. Okay, so there have reasons why they try to keep the distance between the two plates here. Okay, is too big also will have a problem. If too short, I mean too smallest gap also will have the problem. Okay, so based on this one, they just shows to you we had the positive 2q. Why? Because of the area. Okay, due of the area, the ions in the area will be more. Okay, when the is a small plate, it means they're not going to occupy a lot of ion in the plate. Okay, when it's the largest, then they're going to have more charge on the plates. Same goes to your negative charge here. Okay, why they put as a -2, I mean -2. So now you have a look on the formulas. Okay, this formula is very important for you to know, because from here you need to justify, not justify, you need to prove based on your theory that what you're doing is right. Okay, so example, let's go with the equations here. Okay, this equation they shows to you, you have C equal to, and you can see the word, I mean the alphabet E like Italy, where we call as a primitivity. If you remember the word, the symbol here, this symbol, where we call as a primitivity of the medium. Okay, it means this one. Okay, and where we have times with the A. So A means is the area. Okay, take note, A means is the area. At the same time, you may have a look the D. D means the distance between the two plates. Okay, what will happen? Okay, in this part, they try to uh, connect it based on your value of your capacitance with the area. So unless based on your value of capacitance increase means is the value is more higher. That's the one they're using the word increase. At the same time, you may have a look on the area. So when the area getting bigger, indirectly the value of your capacitance going to increase. So that's the one they call, that's the thing they highlighted as an increase. And what happened to your distance? Distance usually we try to keep the same. Okay, but at the same part we also try to play with your distance to check what happened to your capacitance value when we have a smaller distance, when we have the largest distance here. Okay, but based on the first term, I mean the first condition, take note, in the first condition they try to test based on the area. They're not going to test based on the distance, but they only test based on the area. So when the area of your plates is increased, take note the value of your capacitance going to increase. Okay, write down. So those using a slide, you just write down at the side. Okay, and have a look in the figure number 3 and figure number 4. Okay, based on the figure number 3 and figure number 4, okay, this shows you based on the part where is based on the distance part. Okay, just have a look based on the distance here, even though they highlighted based on your plates here, positive charge, positive charge. After that, you have a multiple charge based on the two charge here. Okay, based on the area part. But when it's come to your distance, just have a look. When your distance getting bigger, what will happen? Okay, so whenever your capacitance value is means the value of capacitance increase, area they're not going to touch anything, but your value of your distance will be this increase. Take note this formula. Okay, so either one you can explain or you can justify. Example, you have two questions. Example, Miss asks you to compare. Okay, I give you a value of this capacitor A, then after that Miss give you a B capacitance value. So I will try to, Miss will ask you to compare. Okay, what you can see from the A calculations, what you can see with the B calculation. So when you compare the A calculation with the B calculation, you must relate it to this equation. How is it? You take note. So it means when your area increase, automatically your capacitance value is going to increase. Or you're going to use the what happened to your value of your capacitance. Okay, take note based on this formula, how you need to explain when they ask you to explain based on the parallel capacitance, based on your area and also based on your distance. Okay. So let's say I think we have some calculations here. Okay. Okay. Just have a look on these slides here. Okay. In this slide, the same thing. Actually, this represents the same thing, but this time they highlighted based on the permittivity. Okay. So just have a look on these slides here. Based on your source, okay, as usual, you have the supply here. Okay. Take note, sometimes misuse the word source, sometimes I use the word supply. It's the same thing. Okay. But in the supply, we have a DC. At the same time, we have a AC. DC means it's a direct current. AC means alternative current. But when it comes to your capacity, we always assume it's a direct current. Okay, supply battery. Okay, at this point, they shows you have a plate you have the first plate, you have the second plate. At the side here, just have a look on the side here. They shows you based on the permittivity. And this permittivity are related based on your dielectric. It means this part. Okay, the middle line, the surface or the surface which is make a separations between the first plate, okay, with the second plate we call as a dielectric. If you still remember, the term is dielectric. Okay, and this dielectric where we're going to use a measurements value based on the material where we need to take note based on the permittivity. Okay, and this permittivity where they already specific for you permittivity R. Okay, if you remember, this permittivity R is means related to relative. Okay, and take note, relative is means usually they can change your materials type. What type of the material? Sometimes they only to say going to point out for you a free space. Okay, they just specific for your free space, or they're going to say as a hair, or they're only going to say as a vacuum. It depends what type of materials that you have between the two plates. Okay, example, the one that shows you in terms of your examples based on the medium. Okay, so you may have a look based on the force, or they say based on the medium. They say it means the permittivity is more bigger than one. Okay, it means they're not going to use based on the hair. They're not going to use based on the free scale, free space. They have different material. Okay, that's why the specific for you, the relative permittivity is more higher than one. Okay, and where at the same time they just let you know attracting more possible opposite charge on the plates. Okay, indirectly your capacitance value going to increase. So this material, the material that you're using here is one of the factor going to affect based on the capacitance. Take note your distance, okay, and also the materials that you have here, this material will affect the value of the capacitance. So this is one of the important factor, or we say important parameters that you need to know based on the medium type. Okay, let's go with the next one. Okay, this is where they shows you in terms of the movements of the electron. Okay, later on I want you to download, each of you I want you to download and have a look carefully based on these slides here. Okay, because they shows you the flow of the currents, how is it works. Okay, so let's have a look on the first figure. I call this is the first figure, second figure, this is the third figure. Okay, and where they try to relate the word with the charge with the discharge, what will happen? Okay, when the part when we can assume the capacitance we can say as a discharge, or when we can assume the capacitor is in the charge mode. Okay, so in terms of the first figure, you may have a look. This shows you in terms of the battery symbols here, which is connected to the plates here. These plates where we're going to count it as a capacitance. Okay, and where they shows you the directions of the current flow. You may have a look the arrow here, the directions of the current flow. So from here they already for you the charge can move freely through the wire. So this is the one they call as a wire. Okay, at the same time they already specific one things here is based on the charge flow from the electrode. It means this one, this plates here leaving a negative. At the same time they shows to you the charge, the flow through of the battery. Okay, how is it works based on the charge flow. And the next one they specific based on the charge, positive charge of the electrode at this point. Okay, so this is the one that shows you in terms of the uh, portions, or we call as the movements of the electrons. Okay, now have a look at the side here. Suddenly they come up with triangle shape. So take note that they're using a triangle. Okay, this we call as a delta, or in a certain part we call the changes between the value, the changes of the value between electrons, or between sorry, not electrons, between the voltage, or we say the changes between the current. So just take note, sometimes they're using the triangle shape to define the voltage drop. Okay, the changes. Sometimes they say the word delta, but when it's come to the calculation, just specific the changes happen. Okay, so in the moment of the changes stop when the BC, so it means the changes on their capacitance voltage is equal to the battery voltage. It means the charge that you have here, okay, and the charge that you have in the battery are equal, are balanced. Okay, what happened? It means we assume, okay, we take note the capacitance is fully charged. Take note the charge into the plates or into this material, okay, which is equal or we say balance, okay, where they're going to point out the word charge is fully charged. And have a look on the number 3. At the number 3, they shows you one more thing is where the battery is removed, okay, and where the capacitor remain charged with the differences charge still equal to the battery voltage. Okay, that's why they're using the word charge with the word discharge. Okay, so once your battery, once your capacitance is fully charged, okay, it means we can take out the source out. Okay, but when it's discharged, it means we the charge on the plate is a increase, then you need to add the battery to charge back. So that's why we say these two terms is quite important for you to know: charge with the discharge. Usually when you say your capacitance is a fully charged, it means the equal value or the measurements value are similar. Okay, not, we can't say exactly the same, but in your slide they're using the word equal. We can't exactly make an equal value. Sometimes they have some tolerance based on the point form, but we just assume equal, balanced. Okay, so just take note based on the movements of the electron, how is it works and how, why they say it's charged, why they say discharge. Okay, full charged. So when the term they're using a full charged, it means in which condition they highlighted to you a full charge capacitance. Okay, okay, so it is based on the polarity drift based on the electrons. Okay, let's go for the next one. Okay, the next one is quite important for you to know based on the formulas. Okay, Miss Latino is one of the important formulas that you need to know based on the capacitance. Okay, and at the same time, they highlighted you the factor. Beside the one, the factor based on the electric, okay, based on the materials, they also have different factor which is affected based on the capacitance. Okay, let me go with the point here first. So most of the things they just highlighted to you based on the capacitance, which is stand with the two parallel plates here, okay, and where specific based on the area plates and also they are specific based on the spacing between the plates, where we call as a D, and where the D is stand for the electric thickness. Okay, it means this one plate spacing D, which we call as a dielectric thickness. At the same time, we have the area, the A. Okay, and how is it works based on the factor here? So they highlighted to you. They have a few factors which affected the capacitance. Okay, the first one called as a permittivity, absolute permittivity. The second one is a relative permittivity. The third one is based on the area. The fourth one is based on the thickness of the dielectric, okay, in the meter. Okay, and take note, okay, as in we did for the charge, right, based on the voltage, and some of the terms we say if time means we take note based on a second. Okay, same goes to your capacitance. When they have some calculations based on your distance, always go with the meter. Okay, in case they give you the value into a cm, okay, it's always be careful when you do a calculations. Okay, some unit we keep international unit as a meter. Okay, so that's the reason they always take note. If you calculate based on the area, they say as a meter square root, a power 2, sorry, power 2. Okay, and the thickness of the electric in the meter, they highlighted in the M. Okay, so these are the four which is affected based on the capacitance. Okay, okay, and have a look on the formula. Just have a look on the formula to find the value of your capacitance value, or we say as a capacitor. They have equations. They substitute the equations. Okay, or not substitute the equation. They shows you equations where you need to substitute the value into the equations. Okay, the first one they have the permittivity. Then they have the permittivity based on the relative. Okay, this is the basic formula that we always need to know. When they are always without any O or without any R, this is related to the permittivity medium. Okay, this is a medium. Okay, and where which is equal to absolute with the relative. Okay, at the same time, the times with the area. So that's the reason you need to know the value of the area of the plate. divide by the d. So d means the distance between the two plates, and where the measurements value will be in the farad. Okay. So just take note the equation. Those want to write, you may write the equations. Just write the equations. Okay, let's go for the next part here. I hope you're done. Now have a look on this part. Okay, increasing the capacitance. Okay, you may have a look on the pictures here. The difference picture. Just have a look on the pictures here. So they just let you know increasing a capacitance. Okay, server splitted of your parallel plates can be used as shown in the figure below. Okay, just have a look on the figures here. You just have a look on the figure, yeah. Okay, on this part, you may have a look. They highlighted to you as a positive. They highlighted to you as negative. Okay, which is connected to this one, negative, this point, connected to this point, connected to this point. At the same time, the positive polarity, it means the charge of the ion positive is connected to this line, connected to this line, and connected to this line. Okay, at the same time, it's connected to this line, is also connected to this line. The negative also going up to this point and this point. Okay, what you can see, what they mean here is actually where they arrange the parallel plate is a multiple parallel plates. Okay, so that's the reason they shows you in terms of the split. Okay, based on this diagram. Okay, when you draw a diagram, be careful when you draw, because they say multiple means they can have a multiple plates between the plates. Okay, so example, you have 5 capacitance or you have 7 capacitance. They're going to arrange based on the parallel. So that's the time they say, okay, this is a positive, this is a positive, this is a positive capacitance. So the rest, I mean the bottom, okay, this is a A1, this is a A2, this is a A3. So this is a B1, this is a B2, this is a B3. So all the A will connect it to your positive ion, it means positive polarity. The B, everything is connected to the this one, to the negative polarity. So that's the one they try to bring up here based on this diagram. But in terms of, they're not going to show you in terms of the plate, but they just show to you in terms of the line. So it means not necessary we only need to find for one capacitance. Sometimes you need to find a value of the capacitance for the multiple of the capacitance. Okay, so just go for the next part here. Okay, in the next part, okay, before we go with this part, okay, Miss want to go back here. Just take note. Okay, just have a look on the formula. Just have a look on this formula. Okay, those write down the formulas in your OneNote, or sorry, in your books. Okay, you just have a look. Okay, permittivity area divided by the distance. Okay, where we get the value of the capacitance. Okay, let's go for this slide here. Okay, slide where they set as a proportionals of the numbers of the split. Okay, at this point here, they specific. Actually, the formulas are the same. Just have a look. The formulas are the same, but suddenly you can see they added the word or the alphabet and. Okay, you may have a look. They added the word and. Okay, where the specific is a proportionals of the numbers of the split. It means go back to. Excuse me. Go back to this diagram back. Okay, this is the one they call as a split, a server split. Okay, so that's the reasons the and come into the equations. Okay, you may have a look this and. So this and actually represent how many split that you have. Okay, or how many numbers that you have based on your capacitance. Okay, the numbers of the capacitance. And at this point where they have a -1. Okay, and usual the same thing divided by the d. So the basic equations where we have this one, a divided by d. Okay, but this one they just add n minus 1. Okay, be careful why they say n is the numbers of the plate. Okay, how many plates, plates that you have. So this n represent as a plate. Okay, and suddenly they shows you -1. Okay, means let you know why they using -1, because we just want to take note between the space. Okay, this formula, why they implement this formula, because the first part they take note the numbers of the plate, they -1. Okay, example, me just let you know. You have okay, example, you have 1, 2. Okay, so you have the space that you need to take note. Even though you have uh, many plates here, okay, we always care about the spaces between the plates, how many plates that you have. Okay, so example, it is one, two, three, four, five. Okay, five, one, two, three, four, five, six. Okay, I just put the numbers here, easy for us to define. Okay, one, two, three, four, five, six. So example, you just think about that you have six plate. Okay, plate one, plate two, plate three, plate four, plate five, and plate six. Okay, the most important things that we're going to see is based on the space between the plates. So when when we have a look on the space, it means we have one. Okay, example, I just put A. The second one, the space between these two plates, I put as a B. Okay, and the space between these two plates, I put as a C. The next one, I put as a D. And the space between this, actually, we have space between here is a E. So when I counted A, B, C, D, E, it means the space that I'm going to have is 5. So that's the reason they always ask you to take note how many plates that you have minus with the 1 because we just want to define the space between the plates. So that's the reason they're using this equation. Sometimes some students, they directly directly substitute the value directly because they already know how many plates, they always minus 1, they get the space between the equation. Okay, so be careful when they ask you to calculate based on a multiple capacitance because when Miss go through some of the students, Miss no all the students are smart students, okay, but sometimes they quite careless, okay, when they come to this type of questions part here. Okay, so just take note of this one. Okay, let's go with the next one. Yeah. Okay, in the next example, okay, let's do one example together. Maybe you will have more understanding. Take note, most of the thing that Miss explained to the theory part maybe is quite boring for you, okay? But when you start to do a calculation, that's the time that you will understand, okay, why we're using this, how we're going to relate in this equation to the questions here, okay? So just take note on this part here. So I go on with one example here. So this is quite easy examples also, okay? Just have a look on this part, okay, and most of the thing your maths are how you convert it to cm power 2 when it's come to the meter power of 2. Okay, so the first point here, okay, sorry, the first question here, they ask you the ceramic capacitance have effective plates area of 4 cm. Okay, take note, they highlighted to you is 4 cm power of 2, okay, which is separated by 0.1. Okay, is where is millimeter, so they wrote as a mm of ceramics of relative permittivity where the highlighted is 100. Okay, so we assume we assume we not, okay, relative permittivity where we know it should be in this form. Okay, at the same time, okay, we just assume we don't know how to calculate. Okay, so then they ask you to calculate, okay, the capacitance of the capacitor in a microfarad. Okay, at this time they already specify for you. They not only ask you to calculate the capacitance, it means the value of the capacitance, but at the same time, they already specific for you a few things here. I mean, they already specific one thing here. What is it? They ask your capacitor in microfarad. Okay, so no matter once you get the answer, you must be converted your answer in a microfarad. That's why Miss said when you do any calculations in engineering, better keep in a scientific value. So in this question, they already ask you to find in a microfarad. Okay, maybe you can get minus 13 or you can get minus 16. Okay, but where's it? At the point where you need to convert your answer in a microfarad, the scientific value. Okay, so let's go on with the one by one here. Okay, I'm going to write down, just assume we don't know anything about the equation, how to be substitute calculated in a. So we write one by one first. Okay, so let me write this one here. Okay, I always occupied a big space here. So oh, they have two questions. Okay. Okay, we ignore the answer first. Okay, this one I want you to try later on when you have time. Okay, we just ignore the answer first. Mm. Okay, never mind. We just ignore the answer first. Don't have a look on the answer. Don't depend on the answer. Okay. Okay, we just assume we don't have the answer here. Okay, so let's go with the number one here. So this is the one. Okay, I'm not going to repeat back. Okay, so in actually we have two questions. Okay, based on your slide, we have A and with the B. So we go on with the A first. All right. So I'm going to write one by one here. So I'm going to specific here. Just have a look. So the first one, we need to know the area. So based on the area, they already highlighted is 4 cm. Okay, we just want to put a mark here. Area is A, which we specific as a 4 cm power of 2. Power 2, right? Yeah. Okay. After that, at the same time, we can write as this formula. Okay, 4 time with the 10. Okay, where I'm going to specify as minus 4 power of 2. So you need to know why Miss wrote minus 4. Okay, when in the maths, okay, take note your centimeter power of 2. Alright, so the next one you have the D. D means is the distance. Okay, so let's see how much the distance they given to you is 0.1. Okay, so I'm going to write as a 0.1 mm. Okay, equal to which is 0.1. Okay, since they don't have any power here, so we can directly write the answers of the milli. So times 10 minus 3 meter. Take note of why Miss have minus 4 is due of your power of 2. Those doing a maths, you will know why Miss wrote here as minus 4. Okay, it's because of the area power of 2. Okay, and after that, they also highlighted for us based on the relative permittivity, which is 10/400. So just substitute the value here. It means we're going to write permittivity. Okay. Before that, okay, this is a primitive relative which is 10/400. Okay. So I think we're missing something here. Okay, but before that, I just want to write the equations first. Okay, I need to define the equations first. So the equations, when we refer to the slides here, just have a look on your slides here. The equation that we need to use is this the one. This is the equation that we need to implement or we need to apply. So this means C equals to absolute relative area divided by the distance. So we get in the farads. It means the unit. Okay, from here, the information they given to us here right now. Okay, we are missing one of the information, which is this one. Okay, so what's the value that we should have here based on the absolute? Okay, so as Miss let you know, we can go on with the 2.25 or 245. Okay, so I take the two decimal number 8.85. Okay, times 10 minus 12. Okay, minus 12. And where? Okay, we up to us whether we're going to write the unit or not. So this is absolute equations formula. Take note about this one. Okay, so once we already have this equation, I mean we have the value of this absolute value, we already have the value of the relative. At the same time, we have the value of the area. Okay, and we already have the value of distance. You just substitute in the equation. So let's calculate the equations. So it will be 8.85. Take note that don't have a look on the answers. Miss always have a look on the step, how you done your step. okay, minus 12 times with the 100. Okay, this is where related to the relative. This related to absolute. Okay, then times with A, area. I'm not going to take 4 cm because I need to convert in the meter, okay, which is power of 2. So that's the reason we have 4 times power minus 4, okay. After that, divide by the distance. So the distance after I convert is 0.1. Okay, not necessarily need to convert. It's up to you. Okay, you can write directly. Okay, so I shows Miss shows this one. I shows this one because maybe you have confused why he's a minus 4, this is a minus 3. We maintain the same based on the milli because this is a power of 2. So that's the reason we have minus 4. Okay, so we have 0.1 times with 10 minus 3. Okay, so once you done, you can get the answers here. Okay, how you done? The last answer. Okay, your last answer, calculate. Anyone, don't refer to your slides. Who know your slide answer could be wrong. Okay, so we're not going to depend on your slides answer. I want someone to calculate and define for me the answer. Anyone in the meeting chat, can you let me know the answer? Okay, there's someone give me the answer 3, 5. Okay, let me write here at the side here first. 3541.6. Okay. Okay. There have 2% give me the answer. How about the others? One more person can give me the answer? Hmm. Just substitute in your equations and calculate. Anyone? Anyone? Yeah, okay, that's someone give me the answer. Yes, 3.54 power of 9 is 9. Okay, 9 is 9 is a pico lah. Okay. Oh, pico is should be minus 12. Can you convert to minus 12? That one is power minus 9. Okay. All right. So some of you get exact. Okay, let's see your slides answer. Okay, your slide answer they given here is 3,540 picofarad. So some of you get the exact value, which is 3540, and some of you get some based on 3541. Okay, is due of some tolerance value. Okay, you may use this the one maybe the absolute value they use a 3 decimal number. So the one misused is 2 decimal number. So they have some tolerances could be happen. Okay, so in terms of the tolerance answers, miss always accepted. Okay, so right now. Okay, we can go on. Okay, I just wrote this one 3540. Okay, power of minus 12, which is equal 3540. Okay, it's a pico. We can stand as a pico, huh? Correct. Okay. Any decimals numbers, okay, due of your tolerance value, Miss will accept it. Okay, but they have a big difference, then Miss say the answer is wrong. Okay, so this is one of the examples here. Okay, let's go on with the second point here, the B. Okay, in the B, Okay, in the B, I think it's quite simple. B, they ask you calculate the part A is given a charge. Okay, where they specific for you the charge 1.2 micro C. And what will be the PD between the plate? It means are referring to the voltage, right? Okay, so take note, if you see A and B are related. So usually this the one always you can see later on if we have a tutorial sections, okay, you always can see the questions are related to each other. So when you do a calculation, be careful when you do a calculation, because when you give, okay, example, we have A, we have B, and we have C. Example, I mean, just want to specific here. Okay, example, we have question A, we have question B, we have a question C. Okay, sometimes the question B are related to your A, at the same time your C are related to the B. Example, when you provide the answer, you calculated for the A answer. Example, we say 5 micro. Okay, when you did some mistakes on your A, you will bring up the same mistake to the B. So when you did the same mistake at the B, you bring up the answers of the incorrect answer to the C. So sometimes your questions will be related, interconnect each other. So be careful when you do a calculations here. Okay, so that's the one we want to point out here. Okay, in the B, they already let you know the things that we need to find is a potential. Okay, it means based on the potential differences voltage. Okay, now we can substitute directly because it's quite easy for us to substitute directly. The first thing we need to know the the formulas. So it means charge equal to the CV, right? And where we change the equation to define the voltage value, this value. So V equal to the Q over C. At this point, already given to us the value of the charge. So how much is it? 1.2 micro. Value they given to you, 1.2 micro. So substitute directly 1.2 micro. All right. So 2 micro divided by the charge. So at this point, you must provide the right answer. Okay. In case your answer is wrong, then your B also the answer will be wrong. So in this part, means just go on with this value 3540 times 10. Okay. Pico means it's minus 12, not minus 9, it's minus 12. Okay, so minus 12. Okay, we'll get the last answer. So the last answer, okay, based on your slide, the given is 339. Okay, someone calculate, define it whether we get the right answer or not, whether we get 339 or not. Okay, those with the value of 3541.6 pico, you may calculate too based on your answer. What you get your answer? If you get 1.2 micro, okay, with the 35416, is it? 16, yeah, 141.6 pico. Okay, what's your answer? Okay, do you get 3339 volt? Do anyone get different answer? Those done this one, can let me know how much the value that you get? Okay, some audio. Okay, all right, 3.3, 8.83. Okay, 2 decimal number is more accurate. Okay, all right, this is 3, yeah. Okay, this is 3. Okay, so when you round up your number, you nearly will get 3.39. So that's why we say your answer is right answer. Okay, so this is quite simple. Miss can say this quite simple exercise. All right. Okay, let's see the next one. Okay, we still left 15 minutes. Okay, so let's see whether we have. Okay, just this one. I leave it to you. Can you try to get your answer? Can you send your answer by 12:10? Just try this one. Just try. Those can do, you can do it and send your answer in a meeting chat. Can we see together your answer, how you did the calculations? Just try and error. Just try and error. The example they given here, a parallel plates capacitance F19. Interval leaf plates. Okay, take note. Okay, they highlighted you 19, 19. Okay, where you have the interval leaf plates, each 75 millimeter by 75 millimeter, separated by the mica sheets. Okay, this where they're using mica wood. Okay, all right, which is based on the thick. So when thick means, of course, you need to know is based should be the distance between the two plates. Okay, And assuming the relative primitive of the mica is 5. Okay, they already highlighted to you. The relative permittivity stand for 5. Okay, sometimes the mica, they have their own range. Please remember, they put as 4 to 8. Okay, but for this question, they already specific for you. The relative primitive stand for 5. Okay, so you don't need to refer back any tables here. Easy for you. And what they ask here, calculate the capacitance of the capacitor. Okay, they already give you the value here. Okay, don't have a look on the value. Ignore the answer here. Please don't look on the answer. Okay, I want you to calculate, write in your piece of paper and send to me in the meeting chat. I just want to have a look on the calculations part. The step, not the answer. Miss only not going to see the answer. I always see on the step. Because when you did a mistake on your answers, okay, you still have the marks on your steps. Okay, so I want to see your step. Don't send me the calculator pictures with the answer. Okay, I want you to show in terms of your calculation, the formula, how you substitute the value. The same thing they given to you in a millimeter. Just now I was the previous example cm. Can anyone try? Show me the step. Hmm. I give you 10 minutes. Just try, just try. Try and error. Okay, but don't look on the answer. Be careful with the area calculations when you try to convert to meter. Hmm. No, I'm not talking. I'm waiting for your step. I just want to see your calculations, how you done for this example. Oh, okay. I just want to see your step based on this example. Okay, I get one response very fast. Okay, I just want to get some more two response. Is it okay? Anyone? Just try. But don't have a look on the answer. Okay. Some more to respond. Okay, I have one more response. Just try, just try. I want you to try. It's okay if you cannot get the exact answer from the slide. Just try and error. Okay, I get one more response. Okay, let's see. Uh, Minimize the slide view. Okay, let's see your friend's answer here. Okay. Anyone, those want to send, you can send. I'm waiting for your answer. Just try. Okay, let's see with the first person here. Cheng Hao. Okay, Cheng Hao answers the steps is okay. I can see it done. Okay, but Miss can point out one part here based on the area. Remember the one Miss let you know in the previous example, because when they specific for you in the cm or millimeter where you come out with a power of 2 meter, but when you convert it, you be careful because it should be -6 or -3 on this one. Just have a look at this one. Cheng Hao. Just have a look. It should be -3 or -6. Okay, but based on the substitute calculations, once you defined it, it's get 22.45 is the right answer. Okay, and where using the formula, this formula, okay, and -1, okay. The answer is the right answer. Just have a look. It should be -3 or -6. Okay, let's see this one. Power of 2. Okay. It's 5.625. Okay. 5.6. Okay, then should be -3. All right. Okay. All right. Let's go with the next person here. Okay, -2 power of 3. Okay, 5 point. Oh, 5 point. Okay, 5 point then. Okay. Okay, have a look. Okay, this is one of your friends give us the answer. Okay, I think this one, just have a look. When you substitute the value directly in your calculator, do you get the answer 22.141? This is something missing here at this part here. Just have a look back. Okay, someone did in the OneNote. Okay, someone give me a response here. Okay. -3, okay. Power of -8. Power of -8. Okay. Try to convert to a scientific value. Let's see how much you get. Either you can convert into a micro or you can go on with the nano. But because they're not specific for you which value they want. Just this is okay. But just take note when you converted the value. Miss Cheng, how did correct? It's -6. You already changed it to 1.5. Okay, so it's power of -3. So let's see its back answers. Let me go back. Okay, -3. Okay, 5.6. Oh, 5.6. All right. Okay, if 5,000, then let me zoom a bit. 55 times 5. Okay, all right. Okay, that's good. Let's go with the next part here. Okay, let's go with this one. What is it? Okay, never mind. Okay, this one is -6 because it's 5,625. Okay, power of 8 converted. All right. Okay, let's go with the next one. Okay, so this one, Miss can see you make a direct calculations, substitute value directly. Okay, so when you only want to find the diameter, how much is it? There will be the diameter. Okay, why Miss focus on this one? Because Miss has encountered a few tutorials when I go through with this calculations part. Okay, so when you convert it, even though you make a straight calculation divided for Miss, whether it should be in a -6 or is a -3, it's important for you to know this one because when you make a mistake at this point, it can be affected your last answer. Okay, so all right, so I think everyone did a good job here. Okay, so let's go back to the slides here. I think most of you get the answer, so it should be no problem. So just have a look on this part here. Before we end the class, okay, just have a look. I'm not going to write back, okay, because you already everyone give me the right answers here. Okay, so in terms of the equations, take note the equation that you need to have is based on the capacitance, okay, which is a primitive absolute, primitive R, with the A with the n minus 1 divided by D. Okay, so from here you need to know how many place that you have. Okay, so in terms of this question, the given to you is a 19. So 19 minus 1, you get 18. So that's the reason most of your friends write the answers 18 directly, and some of you shows to me 19 minus with the 1. Okay, and the next one is based on the diameter, or we call as the dimension, sorry, not diameter, dimensions of your plates. Okay, which is 75 millimeter, which is 75 millimeter. Okay, so when you convert this one, take note, either you can get is which is power -6 or you can get -3. Okay, the one miss make a overlook on the previous answers one of your friends here, because when you go on with the this -6, okay, your power you will say as a 5,600 something, I can't remember the value. Okay, 2 something up. If the -3 means you're going to have in terms of the point, okay, 5 point something, then you get -3. So be careful when you converted this value. Okay, and others I think it's easy for you to remember because the absolute value, as I let you know, you can go on with the 8.85 or you can go on with the 8.854. Miss can't remember. You have 3 decimal number, you can have 2 decimal number. Both also you can go on. Okay, but you only can find a little bit tolerance when you provide your answer. That's all. Okay, and as usual, you already have the diameter where it is specific for you in a millimeter. Okay, So this is the one that you need to take note, substitute your value directly. So example, when you substitute, those still doing it, you may have a look your the steps here. Take note, usually means not going to look on your answer. I always have a look on your step. So unless your answer is wrong, you still have the marks on your steps. So I always want to see your step. Okay. So it means you're going to have this equation. I just wrote back here, C. Just give me 1 minute before we end the class today. Minus 1 divided by D. Those still doing it, those are confused, you may have a look on this one. 8.85, okay, times with 10 power of 12, okay. Then you times with 5. In this format means using a bracket, okay. It's up to you. You want to show in terms of the symbols or the multiples also can. It means times. Okay, and the next one I go on with the 5, 6, 2, 75, 75, 75. Okay, should be 2, 5. Okay, power of minus 6 because means go on with the power of 6 here. Okay, and with the 18 because this one 19 divide minus with 1 we get 18, then divide by D with the distance here is 0.2. Okay, before that means let you know how we get the 5 from the this one primitive relative. Okay, this is a primitive absolute. Okay, so distance is 0.2, so you just substitute 0.2. It means 0.2 milli power of minus 3. Okay, so once you calculated, you can define your answer because they not let you know you must get in the nano or you must get in a difference value. So it's up to you. Any scientific value. Okay, any scientific value I will accept it. So maybe some of you can provide to me the answers in this form. 0 0.0, 0 0.0. Okay, let me write with the, okay, 0 0.022224 microfarad. Okay, or you go on with your others answer which is in a nanometer. Sorry, in a nanofarad because capacitance we using farad. So it means 22 point, this is the answer, 22.4 nanofarad. Either you go on with the micro, you convert it into a micro, or you come up with the nano. Since your answer in the slide they given with the nano, I will accept the nano answer, and at the same time I will also accept the micro answer. Why? Because they're not specific for you. We should have the answers in a nano. They're not specific for you. The answer should be in a nano. So those did in a micro also will accept it. Excuse me. Those done in the nano also will be accepted. Okay, so today class we stop here. Okay. So we have other examples. Okay, maybe this example I leave it to you. You may try to do. Okay, this example do it as a homework. I want you to do it as a homework. This one. Okay, don't look on the answer. Okay, don't see the answer. Do it as a homework. Okay, the more you're doing practice, the more you understand the equation, how you want to apply the equations. Okay, do it as homework. Okay, so the next one means we'll carry on for the next class. Okay, but the next Friday, okay, take note, the Friday class will be the discussions, and the same time means we'll go some theory part which we can't cover up on the previous class. Okay, so this one maybe we'll go continue for the next week. Okay, so let me take the attendance before I stop here. Just double checking, does everyone here? Okay, this thing I will see this answer. Okay. All right. Anyone missing here? Let me see your. Anyone missing here? Not missing. Maybe they not attend. Oh, Mama. Mama is not here, is it? Mm. Anyone know any reasons why it's not here? let me stop record. Okay, those close to him or his good friend, okay, just ask him to let me know the reasons why he not